So welcome everybody to the next session of X# Online. Today your host will be Fabrice Fauré from France. He will share his screen and enlighten you about X#, Lambda Expressions and LINQ. Fabrice, the mic is for you.
Okay, thank you. So welcome aboard, and I will try to give you an interesting session, I hope, about Lambda expression and anonymous methods, and also LINQ. We will also talk about code blocks that we have in X#, that is a kind of Lambda expression. So, which that exists since a long time in X-based language, at least in VO. So, okay, let's go first for the Lambda expression. So, Lambda expression is a kind of function or method without a name. We will see a little bit the same thing with anonymous method. It is something that is checked at compile time and has some type parameters. In fact, we will see that you can specify the type of parameters, but if you don't, the compiler will infer the type of the parameter based on their usage. And it will return something if it is needed. So the syntax is very easy to read. You have to put some curly brace in the beginning and at the end. You have to set the list of parameters with that list is comma separated. So you have to indicate the formal name of the parameters. Then you have a kind of go-to sign with the equal in the right chevron, and then we can have the corresponding code. So all this is the Lambda expression, and okay, don't forget the curly brace. That the curly braces that indicate where it starts and where it ends. Maybe we could go for a short sample for that, but maybe I'm too early in my sample. If I go back to my presentation, I also have something with anonymous methods. So it looks like Lambda expression, except that you have to specify the type, and you see the way you write it, you have to specify delegate with the different types between the parentheses. You have to specify the type, but we find again the curly brace for the opening and the closing. You can also write the same thing, and this is where it looks like really a Lambda expression, where you remove the delegate keyword and you place everything inside the curly brace. So this time we have something which is very similar to the previous one, except that you have to specify the type in the writing. Again, if I go back to the previous slide, in Lambda expression, anyway, parameters are type. It's just that the compiler will do the job, check the needed type of the parameter. In the other writing, you are specifying the type that is needed for the execution. So if I go back to my what we have in X#, you can see that I can use that writing. So using the keyword delegate, then indicate the type of the parameters and their type between parentheses. Then I have my open curly brace, the corresponding code with the return keyword, and then the close curly brace. If I want to execute that anonymous method, I'd have to specify that you see it's a delegate. A delegate is a function pointer. So it will point to something which is anonymous. You don't give it a name, but it belongs to a certain let's say template. That's what we have with the keyword delegate on top of it. And I defined a template of an operation. An operation is something that will have an int as a parameter that will return an int as the return value. So when I declare my delegate, I will specify that this delegate will follow this template, the one that we declare on top. And when I set the corresponding code, the compiler will check that with that delegate, we have an int as a parameter, and then that we are returning an int too. So in order to call it now, I specify this keyword and then the parameter I want to pass for the execution. So that's the way you write anonymous method. We can do exactly the same using a lambda. It's easier to write. I just have a plus, but I can change that to a multiply. So we have exactly the same code. It's just the way you write it that change, and the fact that the compiler will infer alone the corresponding type. So I can run that sample. Okay, so I have the execution of the first, oops, I lost my terminal. Where is it? There. So I have the execution of the first anonymous method call, and then the same with the lambda, which hopefully will return exactly the same result. So why do we have two different syntax for that kind of code? In fact, it's just a matter of looking at the code. If I check what is really produced by the compiler, this is ILSpy. So with ILSpy, I will decompile the code, and I can see that if I look at the code through a kind of I don't find my word. So let's say if I look at the code with the version 2 of C#, you see that everything is delegate, because at that time in C#2, Lambda expression wasn't there. So the only way to realize what we have done was anonymous method with delegates. That's exactly what we can see here. But if I change the way I look at the code, and if I jump to the latest version of C#, I can see that in fact everything is Lambda expression. So you see I have an anonymous method and a lambda in my code, but now I have two Lambda expression because the code is, the generated code is the same. That's just the way you look at the code that change what we have. So with ILSpy, if I switch to the X# language, again, we don't have the way I reproduce the code is only through the Lambda expression template. So we lost the writing of the anonymous method, but in fact, that's not a problem because this is exactly the same. We have a plus here instead of a multiply because what we are looking at is the previous version. I think I can reload it. Okay, and now we should have, where is it? No, function is here. Okay, so we now have the right code which has been decompiled and what that we are looking at. Okay, so we have two names for the same thing. It's just the way you write it that may change the way you understand it. But in the end, if we look at the generated code, this is exactly the same thing. In the literature, I've tried to find some sample to what is the difference between anonymous method and Lambda. The main thing that was out was that you have to type the parameter with anonymous method. Okay, but if you look at the generated code, in fact, that's Robert talked about the sugar on top of the language. It's just that the compiler is making the change. It's not you. So the same code will be produced. So what do we have in X#? And it's a long story, that because it was something that we had in Vulkan, it was something that we had in Visual Object, it was something also that we had in Clipper. That was code blocks, and code blocks are still supported today. When we look at the syntax, it is very similar to what we had with the Lambda expression, except that we also have curly brace, but you have to place a vertical bar between the parameters, and that's all. You can't type currently parameters in code blocks. They are always from the usual type, and the return value is also usual. It means that you must be in the Vulkan dialect, or in the VO dialect, or I suppose also in the FoxPro dialect. It doesn't work with the core dialect. Okay, so if you want to use the same kind of code, you have to go to Lambda. If you are in Vulkan or VO, then you can use code blocks. The writing is nearly the same. And okay, let's go for a sample. I may have forgot something in the middle of, yeah, okay, I will go back for that. Okay, so here we have some code blocks. You can have a code block without parameters. You can have a code block with parameters, one or several parameters. And first you write your code block, then you eval the code block. Remember, in the previous sample, in the previous one, it was when we were calling delegates that the execution was done. Now you declare first the code block, and then you cause eval in order to execute, to run the code block. And we can apply, for example, code blocks to array elements, that what we have with the a-eval. So one code block will be applied to all elements in the array. So if I have a quick look at the result, oh yes, sorry, I have to stop first. Let's go. So let's make it a little bit bigger. Okay. So the very first one is the classic hello world. So you see that the content of the code block is considered as a return value. So when I print the content, so I have my, sorry, let's go back. Okay, so I have the content of my code block, which is considered as the return value. So when I print it, I have single hello world. I can use the parameter inside the string, or I can use the parameter, the result of the operation inside the code blocks. And so I have to set to eval the different value of the parameters. And if I use a-eval, we can apply a code block to each single element of the array. So that's what we have here, as we are printing the element in the code block. So if you give the value the array, we have all elements of the code blocks. So again, Lambda and Anonymous are nearly the same. Code block is something else, but it's the same mechanism for the Vulkan of the VO dialect. The question could be, okay, we are using code blocks in our VO or Vulkan or X# code for example, some filtering and some selection, but how can we use it in a pure core dialect in X#? That's what we will have here. It's how to use this Lambda expression. So here we have a sample. The first function, CSV read village, is in the library CSV base, which is here. In fact, in order to produce some element for the presentation, I have used some open data of the French country. So what we have here, I'm reading some information about villages in my area, and I have some information in the village class, and the village class will contain the name of the village, its altitude, the population, how wide it is, so the size of the area, etc., etc. So the question is, okay, if I want to sort the villages with something, I can specify delegate. I can specify the name of a function. The problem is, if you look at my code, that's why the function is called what are you doing? If you don't have the function in your screen, it's difficult to understand how I'm sorting the villages. I have to go to the corresponding function in order to check what's happening, how I'm sorting the elements. So then if I jump to the function, okay, I can see that I'm sorting my collection based on the altitude. This is something that is not really easy to understand with the way I wrote my code. If you look a little bit down, you can see that I'm doing the same thing. I'm also using a sort, but this time I'm using a Lambda expression in order to do the job. In my point of view, one of the advantage is that you have the code in place. So you can see if it is your code or if it is a code of somebody else, you can exactly see what's happening in the sort operation because you have the sorting algorithm under your eyes. So if I run that, okay. The first thing I'm doing is I'm sorting based on altitude, and I will check what is the lowest village in my area. So you have the name, it's a pure French name, and you can see that it is 60 meters high in terms of elevation, and I can check where is the highest one. So Sainte-Eulalie is 1,355 meter high in the area. Okay, I can do the same using the sort. So with the Lambda expression, hopefully I have the same result, which means that in both cases, we are doing exactly the same thing. Again, if I jump to ILSpy, you will see that. Okay, let's go function. Here we are. Oh no, this is not the right one. We are there. Okay, if I look at the generated code, you can see that the compiler decided that it was more efficient to put my function code in the Lambda expression. So in the generated code, in terms of optimization, the compiler decided that instead of using a delegate, a function pointer, to my function in order to sort my list of villages, it decided to transform that in a Lambda expression. And so the first sort operation is not a delegate call, but it is a Lambda expression call. So that's why we have exactly the same code on top in the end. And if I compare to what I have, again, the first one was a delegate call, where the second one was a Lambda call. So the compiler decided to change that. So let's believe that the compiler knows what it's doing. So what can you do again with Lambda expression? You can, for example, there are some extension methods to the list to the collections, and you can, for example, find the first one that contains something. So this is my lambda. I'm using the extension method find against the list of villages. And what I'm doing, I'm looking after all the objects inside the collection. So the objects are from the village type. They have a property called name, which is the name of the village. And then I will check when I convert that to lower, that the name contain La Chapelle, because the name of my own village is La Chapelle sous Aubenas. So we will see how many La Chapelle there are in the area based on the open data information. So I'm looking for the first, or I can look for the last one, or I can retrieve all the elements, so the collection of an extract of my original list. So the method is called find all. And again, you can pass Lambda expression in order to execute something, in order to retrieve that collection. It goes even further, because you see that what I have here, I'm retrieving a collection and I'm then enumerating all elements of that extract in order to retrieve the name. You can go further. You can do exactly the same in a single call using a Lambda expression. That's what we have down, because we have a method which is for each. So I can have a call to the Lambda, and in the Lambda I can have, for example, a check, if, a test. So I can check if the name is, so I can. So you can see that the Lambda don't have to be on a single line, but it can contain more than what we had before with the sort. But again, we can call, for example, the console inside the Lambda. That's not a problem. So what we have also in the sample is, okay, let's have some calculation. I want to check what is the average altitude of all the villages in my area. So using the for each, I can have an addition of all the altitude and then calculate the average altitude of the villages. You can do it that way, but again, based on the use of Lambda expression, there is a method which is called average, where you can set an average of what. And what you just have to specify is the property of the object you want to use in order to calculate the average. So again, in terms of ease of reading the code, I really think that using that average method and the Lambda expression, just specifying the property you have to use, it's easier than the previous one. Okay, let's check that I did not make a mistake and that the results are the correct ones. So this is the code we had previously. So I was looking for the lowest or the highest village in my area. So now we are in the beginning of the code. I'm using the find. I'm looking for the first village that contained the word La Chapelle. So in fact, this is my village, the village where I live. I can check what is the last village in the area that contained the keyword. So you have it there. And I can retrieve an array of collection, an extract of all the villages that contain that, let's say, keyword. So I can retrieve the array and enumerate it, or I can use the for each method to produce exactly the same result. So, and in the end, we had the calculation of the average altitude, either using the for each and the Lambda in order to make the addition and then calculate the average, or I can use, oops, I've done something wrong, I think. Let's go back to the sample. Okay, let's go average altitude. So now I have, now I have both altitude, and we can see the result is the same, hopefully. So it means that calculating one by one, and having the average is the same with calling directly the average methods. Okay, so you see that there are different fields where using Lambda expression could be, I think, interesting and can make the code easier to read, so easier to maintain and easier maybe also to debug in the end.
Can I add something, Fabrice?
Yeah.
What's important for those of us who are coming from visual objects is that these Lambda expressions are strongly typed. So the compiler knows that the X or V or whatever it's called, parameter, is of the type village. So if Fabrice would have made a typo in the source code, which we're not seeing anymore, but if you make a typo, then the compiler would have told us that let's say in the last one, village, which is average, if he would do something altitude 1 or something like that, altitude without E, and then compile, the compiler would tell him that the property doesn't exist. And so it says there's no altitude. So this is a big difference from if you do this in VO, where in a code block, everything would be a usual. So the compiler wouldn't know if the property exists. And now, because the parameter here is passed to average, which says, okay, I'm going to take the parameter out of the T of the list of T, which is in this case a list of villages. It knows that V is a village and that there must be a property altitude which it can find. So this this both makes your source code or your program faster, but also reduces the number of runtime errors because things are found at compile time. I think this is a big advantage. And indeed, if you look in ILSpy, you could see that it's actually typed as village V in this.
Yeah, this is what we have here. That the call of the average extension, we have a V as village where we are using the V altitude. So that's exactly what Robert told us. Even if I don't write the type in my code, the compiler will infer the type based on the usage, and so the compiler will check that this is. That's why it checked that the property altitude was written the right way, because the compiler knows the type of the object that we are using in the average calculation. Okay, so this is for the first part of Lambda. Now we will have to go to LINQ, which is another part of LINQ, which also uses some elements, some collection, and against which we can execute some code. So if you have some question about lambdas, please either take the mic or go to the chat while I'm going back to my presentation in order to switch and go.
Is there any way to cast a code block to Lambda somehow to convert one to each other at runtime or something?
Sorry, excuse me?
Is there a way to convert a code block to Lambda?
I would say not really. Well, the code block is in fact a Lambda expression. Let's put it that way. If Fabrice would open ILSpy, you could see that the code block is actually a Lambda expression that takes usual parameters and returns a usual value. And on top of that, we've given it a parent class code block. But the complete implementation is just like a Lambda expression. So, but yeah, if you would cast it, you would have to cast it to a Lambda expression that takes the usual and returns the usual.
Well, okay, even if it takes usual and returns usual, but somehow at least. If I have a function, external function.
Fabrice is showing it here. You see the code block CB3, the first one. It's written a bit different, but it is of f usual, so it's a function that takes the usual, and in this case it doesn't return anything, but it returns the usual. Oh, actually it returns the usual, that's the f usual, and the second one has f usual usual. That means it takes a usual parameter and it returns a usual value. So this is how it's actually written. And the funny CB source that you see below it is an addition in one of the latest builds that actually adds the toString value of the code block. So in the debugger, you will see the source code that was used to create the code block, which is sometimes useful. But
Okay.
it is a Lambda, but a special Lambda.
Okay.
Okay, thank you.
Okay, great. So now let's go to LINQ. LINQ, which means a language integrated query. So it's a language extension. I think it comes from C# version 3. And the idea is that you have a tool that can work with sequence of elements. So anything that you can enumerate, so anything that implements the interface IEnumerable is able to be used in a LINQ expression. And you can use LINQ in order to filter, to sort element, and to send them to a kind of outputs. We will see that how you can retrieve the result of your query. LINQ is supported by X#, the same way it is supported in C#. So if you find some samples, and we will see that a little bit later with ILSpy, if you find some samples that are written using LINQ, written in C#, transport them, rewrite them in X# is very easy because we are using the same keyword at the same places in same order. So I think it is easy to understand how it works. And if you have some samples you want to try, again, the syntax that we are supporting is X# is exactly the same that the one that we have in C#. So let's go for a sample. I think it is more easy to understand. So, okay, let's close this. Okay, so first I'm looking after small collection, and we will go further with some other open data, some other French open data. So here we have the three parts of what we have in the LINQ query. We have a data source, we have a query, and then we have the execution with the result of the query. So here I have some numbers in an array. So this is an array of int, and I can create my query. So this one will be the result of the query. You see that I'm using a var keyword because the result is not just a simple collection, a simple list of elements. It is something that is more complex that will be created by the compiler when the compiler will check what we have in the query. And it is a kind of IEnumerable type of element which are the result of the query and so on. So it is sometimes very difficult to define, to write by yourself the type of the return value. What you have to know is that return value is also something that is enumerable. So the simple way to write a LINQ query for the return type is use the var keyword and let the compiler do the job for you. Now, what we have in the query, I specify that I'm working on the numbers collection, which is my int array that I've defined on top. And I will extract each element of the array based on that, let's say, local var. So my local var for my query is num. Then I can specify a condition against that num local var. So here I'm checking if the division by 2, the result of the division by 2 is 0, so I can check if it is an even or an odd number. And then each number that will respect that condition will be put inside a special link collection. And that's where I specify that I want to select each element that respects that condition. So now what I can do is enumerate this collection and extract each integer that I have in the inside and use that in order to print their value. So if I run my sample, what I have here is that I'm only printing even numbers in my collection because I extract these numbers there and then I use the extract, the result of the query in my for each enumeration here. If I have a quick look at the ILSpy just to see what's happening, okay, you can see that, okay, let's go in C#, for example. If I go in C#, I can retrieve my numbers where, etc. And if I go to, sorry, X#, I can retrieve again my LINQ expression here. And you can see that we have a lambda. That lambda expression is passed to the where method, which is an extension method. As I'm using an array of int, in fact, the return type of my query is quite easy. So I could have written in my code instead of var, I could have written enumerable long. You will see in the next sample when you are using some objects, checking for some objects and extracting some property and so on, then the type can be complex. So the var keyword, I think, is really a must when you're writing such expression. Okay, let's go for the second sample. Oh, yeah. So now let's rebuild and go to the sample. So I have something a little bit more complex. I still have my array of integers and I'm still getting each one by one, but now I'm checking whose are greater than 2, and then I want the result of that extraction to be ordered by the numbers, but on the descending orders. So if I go back to my ALSpy, you can see that now, as the expression is a little bit more complex than a single call to a where, I can retrieve directly in my decompiled code the lambda expression not the lambda, sorry, the LINQ query that we are using. So what we have in ILSpy is the X# plugin language is now able to retrieve directly the LINQ query that we have in the code. If I check the result of the execution, okay, so I'm looking for all the numbers that are greater than 2, strictly, and then I want the result to be ordered by the element, but in the descending order. So everything is written, it's a kind of SQL for collection in the code. That's why it's called language integrated query. It does the execution is not done somewhere else. It is done in our code on our collections inside the language directly. Maybe, sorry. Oh. Okay. So let's go a little bit. So, okay. Not again. I think I have to another sample for you. Yes. So now in this sample, okay, I'm using a collection of my list of villages. If I quickly go to villages, so villages is a name, a zip code. We have a national code for it. We have the altitude, the area, and the population. So what I'm doing here is I'm querying my collection of villages. I want the result to be ordered by the town name, and I want to check all villages for which the population is greater or equal to 3,000. Yes, the number 3 means 3,000. And then I will select the town. So what I will have here will be a collection of villages, a collection, what I call towns, is a collection of villages, because town is coming from the villages. And I will print the name of the villages. Okay, you will see that there are not that much villages with more than 3,000 inhabitants in the area. Okay, what I've done here is that I check all objects for their population, and then I retrieve the object. But in fact, what I have here is that I'm only interested by the name. So wouldn't it be great if I could just retrieve the name as a result of the query? That's what you can do. That's what I'm doing in the second part of the sample. And you can see that when I select, I can, based on the object, which is a village, I can select only one property of that village. So instead of retrieving the collection of objects and then only extracting the name, I'm only interested by the name, I can specify the name directly in the select operator. Have exactly the same result, except that I'm just printing a name list instead of an object list for which I want to check the name. Okay. So you see that there are several capabilities in the query, but don't forget that you have first to indicate from what a collection, what is the collection that you are enumerating, and what is the element you want to extract from that collection. Then you can order, select using, place some condition with a where clause and select either the object or a property of the object. Okay, in fact, you can go a little bit further. You can create a new type of object based on the query. It is part of the select clause. So remember, in the end, I was first selecting an object, or I was selecting a property of that object. But if I'm using multiple collection, I can now create a new type of object, which is a kind of composition of both. And in the select clause, I can specify that I have a new class, and using brackets, specify the list of properties. But when you specify the class keyword, you don't specify the class something. You don't specify the name of the class. That's what we call an anonymous type. So in a LINQ query, you can specify what you want to enumerate, what are the clauses to apply, and in the selection, you can either select the original object, you can select a property of that object, or you can create a set of property. And in order to use that set of property, you can create a new kind of objects, so a new class, so the anonymous type. You can see that each property will keep its original name. So, for example, I was using the name property of the town. So in my new class, the name of that element will be name. If I was looking after the population, then the new property of the new anonymous type would have been population. And last, don't forget that all object of this new type will be read-only. You cannot write on the object of this new anonymous type that you would have created. So let's go for a sample. Sorry. Yep. Let's close everything. So this one is a little bit more complex. Remember, I have a set of villages. Each one has a name, and what we have is a national code which identify all towns or villages in France. The other set of data that I will have is what we call born, which is in fact kind of electrical terminal where you can recharge your electrical car. And in this open data set, we have the owner of the element of the terminal, the ID, the name of the station, the max power, and the only information of the location that we have is this national code. So I have a set of villages with their national code, and I have a set of the electrical terminal also with this national code. What I want to try is to match these two collections in order to create a new object, which will be the set of electrical terminal in a village based on this national code. So what we have is, okay, let's check all the electrical terminal in my area. So they will have a national code between 7,000 and 8,000. So my area is called Ardèche. So we will have all the electrical terminal in the area. Okay. Then what I will try to do, so let's have a look at the query first. I'm enumerating all the electrical terminal based on their national code. So my condition is where the national code belongs to my area. And what I'm selecting here is the terminal. So I will retrieve this kind of object. So I will have the owner of the terminal, the ID of the terminal, the max power, the number of power delivery connection, etc. So I can retrieve this information. Then what I will try to do is use both collections. I will look after the terminal and I will check, I will join another collection, the collection of my villages in my area. And I will try to match these two collections on the national code. And the national code from the electrical terminal must match the town national code. So my two collections will be attached together through the national code. Then the result will be ordered by town area. So the size of the village is the way I'm ordering my new collection. And you can see that I'm creating an anonymous type here where each object will have the name of the city. And you see that I'm creating a new property. So this property will not be called name, but it will be called city, and city will have the content of the name. Then I will have the population, that I know how many power connections we have and what is the maximum power that we can deliver on this terminal. That's the way, using the query, I can link, that's the way to say it, it's kind of fun. I'm linking both collections, one with just the village's name and population, the other one with just the power of the electrical terminal, and using the query, I'm linking those two collections in a new type with the name of the village and the max power delivery that we have on the electrical terminal. What I will put is console Ricky somewhere there. So we will have first the sort and then the length of both. Let's first run the sample and look at the first two results, and then we will go further. Okay, so I will have to change. Okay, so the first list here is the one that we have here. I have all the electrical terminal in my area with the national code in the beginning, then the number of connection and the max power. Sometimes the open data is not very, let's say the quality is not there. So I have a max power of 22 with 0 connection, which is is incoherent. So anyway, let's forget about the number of connection, and the max power only is interesting. So, and all this was ordered by national code. That's exactly the result that I have here. So now next, whoops, you can see that what I have is the list of all the villages with their population, so I can calculate the average of power that is available for depending on the population. And if you see, for example, there I have a village with 1,000 of inhabitants with 22 kilowatts of power in 2 connectors. In fact, I have 2 terminals. I have 2 elements. If I go a little bit higher, you can see that there I have another village which has 1, 2, 3, 4, 5 terminals with different powers. Okay, what I have done here is I have a new type that have been created by the linking of the 2 collection, the join of the 2 collection. That new type has a city property. That's what we have here. I'm looking after the city property in order to print the name of the village. And then I keep the population as a property population, etc. Okay, it works, that's good, but I would prefer to have a single name and then a list of the terminal that belongs to that single village. Okay, you can do that with LINQ. It's what the way to do that in LINQ is called group. So what I'm doing here is I'm extracting in a list the new type with the name of the town, the population, and then each terminal and each power that is delivered by the terminal. And we have seen that one of the trouble is that we may have several villages that have several terminals. So how to group that information? Well, what I'm doing is I'm again applying a request, a query to that generated list. And what I'm doing here against the new created anonymous type, I'm grouping each object by its city name. And I put that in a new group. What we'll have as a result is not a simple collection, but it will be a dictionary. And in that dictionary, each element of the dictionary is the village, the city, the name of the city, and then each element that belongs to one element of the dictionary will be the terminals. So if I go again, what I have here, but I have ordered by the name of the city. So if I go back, it was Saint-Andéol with a B. Yes, here it is. It is the one that had 5 terminals. So I'm printing the name of the key of the dictionary, which is the name of the city. And then I can enumerate all elements that is inside that is attached to the key. So I can retrieve my 5 terminals for that village. So you can see that if I go back to my code, first I linked those 2 collections coming from 2 different sources. I linked this through the national code. Then I created an anonymous type, and I so have a collection of this anonymous type. And then I'm grouping this result into a dictionary where the key of the dictionary is the name of the city. So you can see that, okay, if I was again a SQL database, I could have done nearly the same thing. But again, I'm doing that not on a SQL server. I'm doing that against my own collection in my own code. Okay, so you can first, if I go, I will say it again. Okay, if I go to my very first query, it was a simple for something other where, and then select that element. You can go further and you can link 2 collections using the join keyword, and you can specify what is the key of the link between these 2 collections, and then create, why not, a new type that is a mix of the different elements. And again, using that new collection, you can group each new object into something which is a dictionary of. Okay, you can see that it is very, very powerful. And I really think that it's really interesting to have that power of mixing, selecting. And again, what I think that is really, really great, I could have done that with some for each and while and if then and so on. But really, it's easier to read and I think to understand using that kind of query directly in your code. It is, I think we are more near the algorithm when you write the query than if you had to write that through a set of enumeration with for each and check with the if and then create a new a temporary collection and so on. Everything is here, I think, is more simple. I don't know the good word to use, but I think it is more clear to understand what we are doing against the collection. Okay, I'm done for the one for I have a little extra there, which is a little bit out of the topic. So let's go. And then we will go for the question if you have some. It was just because I was using that in my sample, in my previous sample where I was initializing my array using brackets and each element. This is something that we support in the X# syntax. You can create objects calling their constructor, and you can, after the call to the constructor, you can open a bracket and set the name of the property with the value that you want to set to these objects. You can write that on several lines if you are using some semicolons, or you can write that on a single line. So I'm calling the no parameters constructor, and then I'm initializing all the properties after the constructor. So this is called object initializer. And you have the same thing with collection initializer. If you want to create a list of villages, for example, and using the town that I have there, you can open the bracket and set the values that you want to put in the list. So if I want to check the result of this sample again, let's go. Okay. So it's a little bit off topic of the Lambda and LINQ, but I think it is useful too. So you can see that you can initialize object in a single line, and you can initialize a list also in a single line. Okay, this as this was something I was using in my sample, I thought it was interesting to have some explanation. Okay, I'm done for the presentation, but if you have some question, can go back to LINQ and maybe you could try to give you some explanation, but I see that there are also a lot of discussion in the chat that I missed. Thanks to Robert for replying to all of these questions.
Yeah, you're welcome, Fabrice. It's not that much. It was just someone answers really long sentences. That's me. Thanks a lot for this very clear and explaining presentation.
Thank you.
Yeah, I would recommend everybody have a look at Lambdas, have a look at LINQ. Don't use it everywhere, but use it when appropriate.
So there is a question, Fergus is asking, yes, all the sample, all the material that you have here, that you have seen, everything will be available on our website. So the recording of the session will be put in the X Sharp Academy YouTube channel as soon as we can. And we will have a zip file with the PowerPoint presentation and all the source, all the solution, the open data files too. So you can run again the sample the same way as we have done on the session now. Okay. So if we have no more question.
I think you did a good job, Fabrice.
Okay, thank you.
Either they're all fallen asleep or you have covered everything, but I don't think they will fall asleep because they start replying now.
Okay.
Okay.
Great.
For next week, we haven't any concrete topic yet. I asked the question on Monday, and I will repeat it now. We can, of course, figure out something ourselves. I think this is interesting. I saw a question today about commands and preprocessor. We are open for suggestions. If you have something that you say, oh, it would be worth spending a little time on, let us know. And then we'll plan a session about that next week. If there's no suggestions, then we'll probably skip a week and come up with something else ourselves.
Yeah, please give us some
So
time to prepare some good sessions.
Yeah, use the forum for or comments on the website for suggestions, and thanks a lot for your attention.
Okay. So thanks everybody, and hope to see you one more time, either on a virtual session or maybe meet in real. Bye.
Bye.
Bye bye.